13 ad math paper, and as you can see, you have 2 hours and 40 minutes to do the ad math paper. It's 4 sections. You do everything from section 1 to 3, and then when you get to section 4, you choose one question. Section 4 is statistics, which is the best topic in mathematics, as well as kinematics, which is motion in a straight line. So you go ahead and you do what you want to do. So let's get started on this paper. Question 1. Question 1 says f of x is x cubed minus x squared minus 14x plus 24. And it says use factor theorem to show that x plus 4 is a factor of f of x. Now this is quite simple. Now if x plus 4 is a factor, then we know that if x plus 4 is a factor, then we know that f of negative 4 is equal to 0. That's what we do know. If x plus 4 is a factor, then f of negative 4 is equal to 0. So that's what we're going to show. All right, so this is what we're going to show now. And so f of negative 4 is going to be equal to, so we're going to put negative 4 into the function. So it's going to be negative 4 cubed minus negative 4 squared minus 14 times negative 4 plus 24. And this should be equal to 0. So when we check it out, what we're going to see is negative 4 cubed, that's negative 64. And then we have negative 4 squared. Negative 4 squared is 16, so this becomes minus 16. And then we have minus 14 times minus 4, that becomes positive, I believe that is 56 plus 24 is indeed 0, because negative 16 minus negative 64 minus 16, that's negative 80. And then this part that says 56 plus 24, this is positive 80. And negative 80 plus positive 80 is 0. Since this is 0, we can conclude hence. So we can just make our conclusion, hence x plus 4 is a factor of f of x. Now that we've gotten that out of the way, let's look at part 2. Part 2 goes further and it asks us now, it says, determine the other linear factors of f of x. So to determine the other linear factors of f of x, all right, we can do it using synthetic or polynomial long division. I prefer polynomial long division, but many persons do synthetic division, so it's up to you. So using polynomial division, you have x plus 4, and you're going to divide f of x and f of x, which is x cubed minus x squared, x cubed minus x squared minus 14x plus 24. So when we do this division, we're going to say x into x cubed, and x into x cubed goes x squared. X squared times x is x cubed. And then x squared times 4, that's plus 4x squared. And then we do our subtraction. When we do our subtraction, we're going to get x cubed minus x cubed, that cancel. Minus x squared minus 4x squared, that's going to be minus 5x squared. And then x into minus 5x squared, that is absolutely minus 5x. Then we say minus 5x times x. Minus 5x times x is minus 5x squared. And then minus 5x times 4, that's minus 5 times 4, I believe that's 20. That's minus 20x. But don't forget, we have to bring down our minus 14x here. So when we bring down our minus 14x here, now we can go ahead and do the subtraction. When we do our subtraction, all right, what's going to happen is minus 5x squared minus 5x squared, those cancel. Minus 14x minus 20x, that just becomes 6x. And then we bring down our 24. Then we're going to say x into 6x. X into 6x is positive 6. And then x times 6 is 6x. And then 6 times 4 is 24. So we're nice. All right, we're nice. When we do the subtraction, that's going to leave 0. Good. So pretty much we can rewrite now f of x as, rewriting f of x as the product of, can be rewritten now as x plus 4 times x squared minus 5x plus 6. So f of x can be written as x plus 4 times x squared minus 5x plus 6. But then x squared minus 5x plus 6, that can be factorized. We can always factorize this part now. X squared minus 5x plus 6, we can always factorize this part. When we factorize this, what we're going to get is x plus 4 times, now x squared minus 5x plus 6, that's going to be x minus 2 times x minus 3. All right, so the other two linear factors are x minus 2 and x minus 3. Anytime you finish a question, I really like when we put it in words, so we can say hence. It's always good to put what we want to say in words. Hence, the other linear factors, are x minus 2 and x minus 3. Nice and easy. And that takes care of that. Those are the two other linear factors. This takes care of the first part of the question. Part 2. Part 2 says a function f of x is given as 2x minus 1 over x plus 2. So it tells us this is part B, and it says that f of x is equal to 2x minus 1 over x plus 2. All right, f of x is 2x minus 1 over x plus 2. And let's hear what they're asking us. The next part of the question is saying find an expression for the inverse function. All right, so to find the inverse, first thing we're going to do is call f of xy. And so that implies we interchange x and y to say x is equal to 2y minus 1 over y plus 2. That is generally what we do. And then we're supposed to make back y the subject. When we do this now, what we're going to get is cross multiply to get xy plus 2x, xy plus 2x is equal to 2y minus 1. xy plus 2x is equal to 2y minus 1. Nice, nothing wrong with that. Then what are we going to do next? Next thing that we're going to do is to make y the subject, we need y to be on the same side. So we're going to bring y over here. So bring over the minus 1 over here to get 2x plus 1. So 2x plus 1 is equal to, bring xy over here to get 2y minus xy. And then what are we going to do next? We're going to factor out y. So factoring out y, we get 2 minus x. Nice and easy. All right, so what are we getting? We're getting that 2x plus 1 is equal to y times 2 minus x. So what that means is if we make y the subject, clearly y, which is f inverse, so f inverse is going to be equal to, we divide both sides by 2 minus x to get that f inverse is actually 2x plus 1 over 2 minus x. That is f inverse. If you're wondering how did I get that, remember f inverse is y. If you just divide both sides right here by 2 minus x, that will give you f inverse. So that's all I did, divided both sides by 2 minus x. And then the 2 minus x right here cancels the 2 minus x right here. So f inverse is 2x plus 1 over 2 minus x. All right, now the next part of the question says, the function g of x is equal to x plus 1. So they give us another function g of x. Let's put that function in a different color. They give us some function g of x. And they tell us that g of x is equal to, what is g of x? X plus 1. So g of x is x plus 1. And then they're asking us to find out what is fg of x. Fg of x means that we put g of x into f. Fg of x means we put g of x into f. That's what fg of x means. So anywhere we have g of x, anywhere we have x, we put g of x there. So it's going to be 2 times g of x where x is, and g of x is x plus 1. So it's 2 times x plus 1 minus 1 over, put x plus 1 right here for x, over x plus 1 plus 2. And this is fg of x. And of course, we're supposed to simplify it. So let's simplify it. This is really now 2x. This is really going to be 2x plus 2, and 2 minus 1 is plus 1. So it works out to be 2x plus 1 over x plus 3. So this is fg of x, 2x plus 1 over x plus 3. Nice and easy, soft, a capital T. Now let's move on to part 3. Part 3 says that, given that 5 to the 3x minus 2 is equal to 7 to the x plus 2, show that x is that expression. So pretty much they want us to solve for x, but don't give the exact value. So part C, you have 5 to the 3x minus 2, and it's equal to 7 to the x plus 2. Anytime the unknown is in the power, you take logs of both sides. Before you do anything, anytime unknown is in the power, take logs of both sides. So the first thing we're going to do is log both sides. So if 5 to the 3x minus 2 is equal to 7 to the x plus 2, then the log of 5 to the 3x minus 2 is going to be equal to the log of 7 to the x plus 2. Nice and easy. That's all. Now if these are equal, what can we do? Bring down the power now. So let's bring down the power. So that means 3x minus 2 times the log of 5. So 3x minus 2 times the log of 5 is equal to x plus 2 times the log of 7. X plus 2 times the log of 7. Nice and easy. What do we do now? We just need to expand out both the left hand and the right hand side. So let's expand out the left hand side. Expanding the left hand side, we're going to get 3x log 5 minus 2 log 5, and that is going to be equal to x times log 7, so that's now x log 7 plus 2 log 7. Now, only thing that's required now is to have the x's on one side. So what I'm going to do is bring over this x over here and bring over that over there. So bringing over the x over here, I'm going to have 3x log 5, 3x log 5, and then I bring over the x over here to get minus x log 7. That's of course going to be equal to, I bring over the 2 log 5 over to this side to get 2 log 5 plus 2 log 7. Nice and easy, nothing hard there. All right. Now see that we have x now. The only thing we need to do over to this side is factor out the x. So when we factor out the x, we're going to be left back with 3 log 5, 3 log 5 minus log of 7. 3 log 5 minus the log of 7, and that is equal to, we can factor out the 2 now, so we factor out 2, and what are we left with? When we factor out the 2, we're left with log 5 plus log 7. In order to make x the subject now, all we need to do is divide both sides by 3 log 5 minus log 7. So when we do the division, we divide both sides by 3 log 5 minus log 7. Nice and easy. And now we know what x is, because this cancels this. So the final answer is 2 log 5, 2 into log 5 plus log 7 divided by 3 log 5 minus log 7. Now 3 log 5, this is the same as 3 log 5 is the same as, I can write that as, I can write that as log 5 cubed. You can write that as log 5 cubed. And so finally, in conclusion, just to put the final answer over here, x is equal to 2 times log 5 plus log 7, 2 times log 5 plus log 7, and all of this is of course divided by log 5 cube, and log 5 cube is the log of 125 minus the log of 7. Nice and easy, soft, no issues. Now we're able to move on to question number 2. Let's go to question number 2. Question number 2 gives us a function. It says f of x is equal to 3x squared plus 6x minus 1. F of x is equal to 3x squared plus 6x minus 1. And then, of course, they're going to ask you to put it in its vertex form, meaning for you to complete the square. All right, we've all been doing this. We've been doing this for so many times now, from Csec math and now to add math. So we've been doing this long. So we can identify that the coefficient of x squared, we call it a is 3, our b is 6, and our c is -1. Nice and easy. Now we have all of these values now, and so now it says express f of x in the form a times x plus h squared plus k. So first we need to find is h, and h is equal to b divided by 2 times a, b divided by 2 times a. And so what is b? b is 6. And so it is 6 divided by 2 times 3, which is 6 divided by 6. And 6 divided by 6 is 1. All right, so that is h. So h is equal to 1. Next we can find k. Now k is equal to 4ac minus b squared over 4a. This is the formula for finding k. I know it's a little lengthy, but we've been used to it now. 4ac minus b squared over 4a. So now, all we need to do now is plug in now what is a. A is 3, and so k is equal to 4 times 3 times c, and c is -1, minus b, and b is 6 square, and then we divide it by 4a, which is 4 times 3, which is 12. That will give us k. So let's work out that. So what are we getting? 4 times 3 times -1 minus 6 square divided by 12, I get -4. And so now putting f of x in the form that they want, we can finally tell them that, okay, f of x is equal to a. A is what? A is 3. So it's 3 times x plus h. What is h? 1. So it is x plus 1 square plus k. What is k? -4. So this takes care of part 1. This is the solution for part 1. Nice and easy. Then it says state the minimum value of f of x. The minimum value of f of x is k. Always remember that minimum value of f of x is equal to k. And so minimum value of f is, what is k? K is -4. That's the minimum value of f of x. Then it says determine the value of x for which f of x is minimum. So the value of x for which f is minimum is x equal to minus h. So that is, i.e., x equal -1. That's the value of x for which f of x is minimum, -1. Nice and easy, soft. So that's part 2 and part 3 done and dusted. Part 2 and part 3 out of the way, nice and easy, soft, 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 soft. Nice. Now let's continue. Now part 3, or part B actually, part B says find the set of values for x for which 2x squared plus 3x minus 5 is greater than or equal to 0. So it tells us that we have 2x squared plus 3x, 2x squared plus 3x minus 5 is greater than or equal to 0. Find the set of values for x for which this inequality is greater than or equal to 0. Nice. So first thing we're required to do is factorize this expression. Let's go ahead and factorize it. All right, it's easy to factorize with the I. How do I factorize it with the I? Well, first thing you're going to ask yourself, 2x squared. That has to be 2x times x. All right? And then the next thing you ask yourself is 5. Which two numbers will times to get 5? That must be 5 and 1. That has to be 5 and 1. 5 and 1. And the next question is, how do I know which signs to go where? This means signs are different, but the bigger number is positive. So the plus goes here and the minus goes here. All right. And it's always good to get a sketch of what's going on. So this is a rough sketch of the quadratic, right? I know it's very poor, it's very tacky. This is the line y equals 0, but the part of the solution that we want is when y is greater than or equal to 0. And so if these are the roots, if this is the root, right here and right here, then the part of the solution we want is when y is above the x-axis. So these are the actual solutions that we want. Nice and easy. Those are the actual solutions. So if this would be x equal 1, this would be x equal minus 5 over 2. Nice and easy. All right. And so the solution that we want is x. Solution that we want is x is less than or equal to minus 5 over 2. X is less than or equal to minus 5 over 2. Or x is greater than or equal to 1. All right. Nice and easy. That's the solution. X is either less than or equal to 5 over 2 or x is greater than or equal to 1. Nice and easy. Now part 2. Part C, rather not part 2. Part C is a sequence question. And it says that find the sum to infinity of the finite series. All right. So part C, it says find the sum of the finite series. You notice that we have 1 over 4. And then the next thing you have is 2 over 4 squared. I like this question, 2 over 4 squared. And then next thing that you have is plus 1 over 4 cubed. Then the next thing you have is 2 over 4 to the 4th power. And it goes on and on and on. But it's a finite series, all right? Now, you may be saying, whoa, how are we gonna do this? But it says the best way to do it, or the hint, is that you can write this as the sum of 2 series. So what does that mean? Write it as a sum of 2 series. We can identify, let's put it in red, the color red. We can rewrite this as 1 over 4 plus, now instead of saying plus 2 over 4 squared, we can put the 1 over 4 cube. Plus 1 over 4 cube plus 1 over 4 to the 5th power plus, we'll continue. And we'll bracket that because this is 1 series plus the sum of the second series now. And the second series would be 2 over 4 squared plus 2 over 4 to the 4th power plus 2 over 4 to the 6th power and so on. All right, so we can break it up as this then. Nice and easy. Nice and easy. Nice, nice, nice. That's what we're doing. Now, right now what we can do is we have that. First thing we can do first is look at this. Remember, the sum of how do we find sum to infinity? That's a reminder. Sum to infinity, remember, is a over 1 minus r. That's sum to infinity. Sum to infinity is a over 1 minus r, where a is the first term. All right, a is the first term of the series, r is the common ratio. So what does that mean? That means that let's call all of this s. All right, let's call all of this s. All right, and so this is a formula for sum to infinity. And so what we're going to call it is s is equal to s1, which means sum to infinity of 1 plus sum to infinity of series 2. S is equal to s1 plus s2. Now, in order for us to know what s1 and s2 is, first and foremost, we need the first term is a quarter. All right, for this. So for this, it is s1, which is a quarter, divided by 1 minus r. And what's the common ratio for this? For this portion, the common ratio for this portion is 1 over 4 cubed divided by 1 over 4. So let's work out what r is. For this one, r is equal to second term divided by the first term, which is really 1 over 4 cubed multiplied by 4. Because dividing by a quarter is multiplying by 4. So that's 1 over 4 squared. That's r. R is 1 over 4 squared. Let's find the common ratio for this side. The common ratio for this side is the second term divided by the first term. So it's the second term is 2 to the 4th power. Dividing it by the first term is really multiplying it by the reciprocal. And the reciprocal is 4 squared over 2. That still just works out to be one common ratio. 2 cancel 2. It should be to the 4th power. 2 cancel 2, and 2 times 4 squared over 4 to the 4th times 2, that's just 1 over 4 squared. So the both of them have the same common ratio. So we get 1 over 1 minus 1 over 4 squared plus 2 over 4 squared over 1 minus 1 over 4 squared. That will give us the sum, the finite sum of this series. So this works out to be, just put this in your calculator. All right, now I'm just going to work out this portion first. So this is really 1 over 64. So 1 minus 4 squared is 16, sorry. So that's 1 minus 1 over 4 squared. That's 15 over 16. And a quarter divided by 15 over 16 is 4 over 15. So this part works out to be 4 over 15. Then we're adding it to plus. Again, down here is 15 over 16. So now we have 2 divided by 4 squared, and that's divided by 15 over 16. That's 2 over 15. So the finite sum is 6 over 15. You may be tempted to want to express it in terms of a lower fraction, but it doesn't matter. So if you want to write it as 3 into that 2 times, 3 into 15 5 times, 2 over 5. That's up to you. You may write it how you want to. This takes care of question 2. Now on to question number 3. Question number 3 is usually vectors.